We're going to continue to explore linear search by writing a function that implements it. This function takes a list and any object, and returns an integer indicating the index of that object in the list. Here's an example call where we search for 2, where 2 appears at index 0. Here's another where we search for 5, which is at index 2. And now we'll search for a number that isn't in the list. We should get back -1. And our description is return the index of the first occurrence of v in L, or return -1 if v is not in L. Now we'll draw our list again in order to help us reason about this algorithm. I starts off at 0. Here's the code for that. We don't know yet when we're going to stop, so we'll leave the condition blank, but we do know that we add 1 to I each time through the loop. After a couple of iterations, we have this general picture. I is some index. We know that v is not here. Now let's look at what this looks like after this loop is over. What if v was not anywhere in this entire list? What value does I have? Well, I is to the right of this dividing line that I've drawn. And in this situation where the value is not anywhere in the list, I is going to end up equal to the length of L. So one way to stop this loop is for I to reach the length of L. We therefore can continue as long as I is not equal to the length of L. The other situation in which we can stop is when I find v at index I. That means that as long as I is not the length of L and v is not equal to L at index I add 1 to I. After the loop terminates, I can check to see if I is equal to the length of L to know whether v was not in the list. If it wasn't, I'll return -1. Otherwise, that means that I found v, and I can return I. Our algorithms that we're dealing with are starting to get more complicated. Drawing pictures like this can really help develop correct code the first time we write it, which in the long run will save us a ton of time. We can actually get our initialization, I gets 0, straight from this picture right here. If I have my list, and I need the v not here section to be empty, that puts the line right there, and that puts I right at index 0. This picture is called a loop invariant. An invariant is something that doesn't change, and this picture describes what's happening inside the loop after any number of iterations. Before index I, we did not see a v. We have not yet examined anything from index I onward, and so we still need to search it. Loop invariants and pictures like these are going to play a big part in the rest of the lectures this week.